The definition of circumference is the distance or length around the edge of a circle. So normally when we measure something or the length of something, it's nice and flat. Like if you measure the length of a room, it's nice and flat. Ruler, measure, tape, and measure. The thing with circles is they're round. So you can't really take a ruler or a measuring tape or something to measure the distance around it. Okay, so we have to use this formula. Formula is circumference. On your formula sheet, this is how circumference is written, so this is how we are going to use it. But if you think about it, the radius is two times the diameter. So circumference can also be written as this. This is what's on your formula sheet, so that's the way we're going to use it. So we take a look at this first example. It says find the circumference of the circle below. Leave your answer in terms of pi. Okay, we're finding circumference, so I'm going to write down the formula for circumference. And my directions say leave your answers in terms of pi. And that means you do not plug pi into your calculator and treat it as if it was a variable. You only plug numbers in your calculator. Pi is going to be in your answer. Okay, so when we simplify this down, look at your circle. What's our radius? 11. So we're going to take 11 and plug it in for r because that's representing our radius. Okay. So if we clean this up, again, when it says leave in terms of pi, we kind of ignore pi for right now and just multiply your numbers. When we multiply our numbers, 2 times 11 is what? 22. So you say 22, and then you tack on the pi as if it was like an x. Okay? What is pi? Like it's representing a number. What's kind of a rounded number? 3.14. Okay? So, but because it's a special type of number, we've created a symbol to represent it, so you just leave it written as pi. So the circumference, I forgot to label, the circumference of this is 22 pi feet. Meaning, if we were to take this circle and unravel it and make a straight line and measured it, it'd be whatever 22 pi feet is, which is, we do 22 pi in our calculator. So the length, if we unraveled that circle and made it a straight line, it'd be about 69.1 feet. That's what that is. Questions over there? Okay. Well, and this next example says given the circumferences, find the radius. Your answers in terms of pi. We don't have to worry. I don't know why that's right there. We don't have to with these two examples. Well, I'm given the circumference of something, so of a circle. So I'm going to write down whatever the formula for the circumference is, which is 2 pi r. And the directions say find the radius, which means that's what we're solving for. We're solving for the radius, which means r can be the only variable in my problem. So I have to plug something in for c. What do you think we're going to plug in for c? 20 pi. That's what the c stands for, circumference. Their circumference is 20 pi, so that's what I'm going to plug in for c. And then we can use that to help us figure out what our radius is. We can solve for r. What do you think we have to do to solve for r? We get r by itself. Be very careful. You're on the right track. We want to move the 2 pi over. But what operation are we doing with the 2 pi and the r? They're written right next to each other. What does that mean in math? What operation are we doing? We're multiplying. What's the opposite of multiplying? Divide. So we're going to divide both sides by 2 pi to move it over. Do the opposite. So the 2's cancel, the pi cancels. We're left with r. Clean this up. What's 20 divided by 2? 10. And then what happens to our pi's? Cancel out. So just our radius is 10, and if we label it's 10 feet based off the units. I'm not huge. If you forget to label, I'm not super picky about that. As long as you get the right answer, that's what I'm looking for. But it's good practice to label. If we take a look at B, it says the circumference is 8 kilometers. And it's telling us to round our answer to the nearest hundredth. Right? Well, I'm given this circumference, so I'm going to write down the formula for circumference. And I'm trying to find the radius. So the radius can be the only variable in my problem. So we have to plug something in for C. What are we plugging in for C? 8. C represents circumference. The circumference is 8. So I'm going to plug C in for 8. And then we have to solve for R. That's what we want to get by itself. What we're trying to figure out. So just like we did here, what do we have to solve for R? Divide by 2 pi. Right? When we divide by 2 pi this time around, is there another pi in the top to cancel out this pi? No. In this example, the pi's canceled out. So we could just say, oh, 20 divided by 2 is 10. Here, there's no pi to cancel out, so we're technically dividing 8 by 2. We're also dividing 8 by pi. We're dividing it by both things. So when it's just a regular number with no pi, you have to remember, put the bottom in parentheses. If you don't do that in your calculator, because it's telling us to round, so that means we're plugging pi into our calculator. Your calculator will read it not how you want it to. It will do 8 divided by 2, which is 4, and then do 4 times 5. It won't do it in the order you want it to. So to tell your calculator that you're dividing 8 by everything, you have to put it in parentheses. So when you plug it in, this is what it's going to look like. You're going to do 8 divided by parentheses 2. To get pi, you're going to hit the second button. And then the pi symbol, don't put 3.14, use the pi symbol. It's this caret button right there. So second, that little caret arrow button next to tangent, hit second, then that button, and pi will pop up. Close parentheses. Don't put 3.14. Anyone need help finding the pi? And then hit enter. So if we round that to the nearest hundredth, how many decimal places is the nearest hundredth? 2. So we would say it's 1.2 what? 7. The 3 keeps the 7 is 7. So our radius is about 1.27 kilometers. Okay. When the directions say to round and you're dealing with pi, that means plug pi into your calculator and round. Like the first one, when it says leave your answers in terms of pi, you do not plug pi in your calculator. You just tack it on in your answer at the end. Okay? Questions over that with circumference? We look at the next example. Mr. Kalidi, Mrs. Kalidi's husband, ordered a small 10-inch Hawaiian pizza from Pizza Hut for lunch one day, which is pictured below. He got to thinking and wanted to know the length of the crust on the outside of the pizza. Right? Then things got crazy and he started wondering, what's the length of the crust on just one piece of pizza? Right? We're going to help him answer these questions below. My husband loves pizza, but he's super weird and he doesn't like cheese on it. Like he'll order pizza with no cheese. Yeah, he loves it. So this situation, he got cheese on his pizza. But, yeah, he eats pizza with no cheese. It was really funny when I first met him. He was telling me how much he hated pizza with cheese on it. Wow, he was eating pizza with cheese. He makes no sense. But, yeah. He compromises now when he gets cheese on his pizza. I don't like it. Oh, that's nice. He's a wonderful person. He's just...
You can order your
pizza without cheese. Pizza with no cheese. He likes steaks, cross sauce, and pepperoni. So when I go out of town and he's on his own for food, I always ask him, like, what'd you eat? He's like, I got pizza with no cheese. Like, he's so excited. Because he has it with cheese when I eat it, so I think it's weird. And if you do, like, half and half, and the cheese just kind of moves its way over. It's like, yeah, but it's just
not the same.
Yeah, it takes sauce off. Yeah.
It's just not the same.
Fun fact about my husband, he does not like pizza with cheese.
There's a lot of sauce.
Your minds are totally blown here, but yeah, he does not like pizza with cheese on it. In this situation, he has cheese on it. So first things first, what is the length of the entire crust of the pizza. Well, the crust is all the way on the outside of your circle, which is essentially, we're trying to find the length of the entire outside of the circle. We're trying to find the what? Circumference. So let's find the circumference of this pizza. So we're going to write down the formula for circumference, which is what? 2 pi r. Okay. Well, we have to figure out the radius. Whenever you order a pizza and it's like, it's a 10-inch pizza, that's the diameter, all the way across. So if the diameter is 10 inches, what's the radius going to be? 5. So our radius is 5. So we're going to plug 5 in for our radius. So when we clean this up, we're going to leave it in terms of pi first and then round. So leave it in terms of pi first. What's 2 times 5? 10. And then tack on the pi. So we want to round to the nearest tenth. So we're going to plug this in our calculator. So we're going to plug 10 pi into our calculator. And all the way around, it's about 31.4 inches. Yes.
It'd be fine if you did 2 pi.
Yep. Yes.
Just do the other formula.
10. That's fine. I just use 2 pi r because that's what's on your formula sheet. But if you know that you're given the diameter, just stick pi behind it. You're fine. Yep. If you remember that. That's just not what's on your formula sheet, so I'm just going to use what you're given. So it's about 31.4 inches. So if you took all the crust off pizza and made it a nice straight line, it'd be about 31.4 inches. Okay. Well, that's the length and time around the entire pizza, around the entire circle. He just wants to know, well, what's the length on just a piece of pizza? What's the length of the crust on the outside of just one piece? Okay? Well, if we think about it, we look at this one piece right here. What fraction of the circle is that one piece? It's 1/8, because there's 1 out of 8 pieces. So what do you think we have to do with 1/8? 1/8 times the circumference, and that will give you, and I'm going to leave it in terms of pi first to get the most accurate answer. So I'm going to go back to this circumference. And that will give you about the length of one piece. So we type that in our calculator. The alpha y equal button is really helpful. Okay? We're going to do alpha y equals enter to get your fraction. 1/8 times the circumference, which was 10 pi. And we're plugging pi in because it asked us to round. If it didn't ask us to round, we wouldn't be plugging pi in. And then enter. So one piece, the length of crust on one piece is about 3.9 inches. Questions over that? Well, what we just did in example 3b is we saw the process on how to find arc length, the length of an arc. Okay, if you recall, the definition of an arc is part of the outside of a circle. It's a piece of the outside. Sometimes we don't need to know the length around the entire circle, which is the circumference. We just want to know the length of part of the circle. Okay? Below is the formula we use to help us find the length of an arc. The only problem is they don't give us this formula. Okay? We have to either memorize it or just think about what we did in the last problem. Okay? When we're asked to find arc length, okay? So, we want to determine the length of this arc in example A, which is AB. Okay? It's no different. This looks like a piece of pizza, right? In the diagram. It's no different than what we did here. We're going to find the circumference of the entire circle, then multiply the circumference by whatever fraction of the circle that arc is. No different. Okay? So let's do that first step. Let's find the circumference of the entire circle. And the formula for circumference is what? 2 pi r. So if we look, what's the radius of this circle? 3. So we're going to plug 3 in. And again, I'm going to leave my circumference in terms of pi first to get an accurate answer at the end. And they told me to leave it in terms of pi, so I can't round. So when we clean this up, 2 times 3 is what? 6. So the circumference around the entire circle, the length around the entire circle, is 6 pi feet. Okay? But we just want to know the length, the distance from A to B. That's all we want to know. So we have to figure out, well, what fraction of the circle is that arc? Is A to B? And to figure out what the fraction is, we have to think about, well, what's the measure of an entire circle? 360. There's 360 degrees around the entire circle. Well, we have to then figure out, well, how many degrees is my arc? 80, because the angle, it's a central angle here. If the central angle is 80, that means the arc's going to be 80. Okay? So this arc is 80 out of 360 degrees. So that's how you figure out what fraction of the circle is my arc. Well, you just take its measure and put it over 360. Okay? What's 80 over 360? What does that simplify down to? What is it? What is that as a fraction? 2/9. So that arc is 2/9 of the entire circle. So its measure, or its length, I'm sorry, is going to be 2/9 of the entire circumference. So all you're going to do is just do 2/9 times 6 pi. And again, your direction said leave in terms of pi, so you're just going to do 2/9 times 6 in your calculator. So we do alpha y equals enter. If we do 2/9 times 6, oh, that's the wrong answer, that's not 9. 2/9 times 6, that gives us 4/3. So our answer is 4/3 pi. Pi feet. That is the length of the arc. Okay? So it's the same process as we did in that first problem. You just find the circumference of the entire circle and then multiply the circumference by whatever fraction of the circle that arc is. You figure out that fraction by doing its measure over 360. Okay? It might make more sense too if we do round. Okay? But keep our answers in terms of the axis. So your final answer is this. Okay? So it's the same kind of steps with B. Okay? First things first, we only want to find the length of this arc right here, E to F. That's what we want to find. Okay? Well, we're trying to find the length of an arc. We have to figure out what's the length of the entire circle. So we have to use circumference. So use that same formula. If we look, what's the radius of this circle? What's the radius of this other circle? 15. So we're going to plug 15 in for the radius, leave it in terms of pi. So multiply the numbers. 2 times 15 is what? 30. Tack on the pi. So the distance around the entire circle is 30 pi. But we only want to know from E to F. So you have to figure out, well, what fraction of the circle is EF? So how are we going to set up our fraction? How many degrees is an entire circle? 360. How many degrees is just our arc? 130. The central angle is 130, the arc is 130. Okay? So that arc is 130 out of 360. Okay? Well, what is 130 out of 360? What is that as a fraction? What is it? And I know that's a weird fraction, sometimes that happens, but this arc is 13/36 of the circle. I know it's a weird fraction, but it's no different than saying it's 2/9 of a circle. Okay? So then what do we have to do with our fraction and our circumference? Multiply multiply them. Yeah, we have to figure out, well, if this arc is 13/36 of the circle, it's going to be 13/36 of the circumference. So you multiply your fraction and your circumference together. And then plug it in your calculator. When we do that, alpha y equals, enter, 13 divided by, or, nope, here we go, 13 over 36 times 30. And you get 65 over 6. Well, yes. Yes. Well, we're leaving it in terms of pi, so we don't plug it in our calculator. Don't plug pi in your calculator. The directions said leave in terms of pi, so you don't plug pi in your calculator. You only plug in the numbers. You'll tack on pi in your answer. So we would leave it at 65 over 6, and then tack on pi. So that would be our answer, 65 over 6. Sometimes you don't get nice fractions like 4/3 or 1/8. Sometimes you get weird fractions like 13 over 36, but the process is still the same. Questions over that? Well, another important thing to know about circles is the area. And the formula for the area of a circle is pi r squared. You're given this formula. You're given the circumference and you're given area. Okay? So you don't have to worry about memorizing these formulas. Okay? Well, let's find the area of the circle in example 5. So I'm going to write down the formula for area. Same, similar to circumference, you just take the radius and plug it in. What's the radius of this circle? 9. So plug 9 in, and then clean it up. It says leave in terms of pi, so don't plug pi in your calculator. Just square the 9. 9 squared is what? 81. And then tack on the pi. When we take area, it's going to be centimeters what? Squared. Good. Centimeters squared. Because we squared something in the formula, so our units are going to be squared. So there's the area. That's how you find the area of a circle. Well, going back to our pizza dilemma, Mr. Collini really got to thinking about his pizza and wanted to know not just the area of the entire pizza, but what is the area of just one piece? Okay.
In the last one, would it be wrong to do 80, like pi is wrong?
I'm not thinking about that. Technically, pi goes after. Yes, but if you wrote it as pi 81, I'll probably accept it. Just draw a little arrow to remind you. Okay. Good question. So we're going to help him, again, answer these questions below. So we want to find the area of the entire pizza. Well, what's the shape of a pizza? It's a circle. So we're going to find the area of a circle. Write down that formula. Area is equal to what? What's the formula for area of a circle? Pi r squared. Okay. What did he say the radius of this pizza was again? From that first pizza problem? Radius is 5. So we're going to plug 5 back in. Okay. We're going to leave it in terms of pi first. And then round. So we leave this in terms of pi first. 5 squared is what? 25. Tack on the pi. So if we round it to the nearest tenth, it's about what? We do 25 second pi. It's about 78.5 square inches. About. So that's the area of the entire pizza. But we just want to know the area of a slice. Very similar to arc length. Same exact concept. We only want to know the area of one piece if it was cut perfectly even. Okay? We only want to know the area of this one piece right here. Well, what fraction of the circle is this piece? Yeah, it's 1/8. It's 1 out of 8 pieces. Okay? So you take what fraction of the circle that piece is, and then multiply it by the entire area. Because the piece of pizza is 1/8 of the pizza, Well, it's going to be 1/8 of the area. And then plug it in. So we're going to do alpha y equals enter 1/8 times 25 pi. And it's about 9.8 square inches. Questions about that? So one more little concept here. From example 6 part B, we just saw how to find the area of a sector. And a sector of a circle is just like a piece of pizza. It is a piece of the circle. Okay? Here's the formula to help us find the area of a sector. Looks very similar to arc length, but instead of multiplying the fraction by the circumference, we're multiplying it by the area. We're trying to find area. So the two concepts are very similar, just different formulas. Okay. So we want to find the area of each shaded region. And we're going to leave our answers in terms of pi. And again, this looks like a piece of pizza. So it's the same exact concept. We're trying to find the area of part of the circle. So we need to find the area of the entire circle. So I'm write down the area formula. Well, what is the radius of the circle? What are we going to plug in for r? 16. So I'm going to leave it in terms of pi first. What's 16 squared? 256. So the area of the entire circle is 256 pi. But we only want to know a fraction of the circle. So we have to figure out what is the fraction. Okay. Well, what angle are we going to use? A circle is 360 degrees. How many degrees is this sector? 45. What's 45 over 360? What does that simplify down to? Right. So this sector is 1/8 of the circle, meaning 8 of these same size sectors can fit in that entire circle. So just like we did, if the area of the entire circle is 256 pi, this sector is going to be 1/8 of that. So what do we have to do with our fraction and our area? Multiply them. So to do area equals 1/8 times 256 pi. So when we multiply that in our calculator, what's 1/8 times 256? What is it? 32? Everyone agree with 32? 32 pi feet squared. Same thing with B. Okay, we want to find the area of this shaded region. So we have to find the area of the entire circle. So area again is equal to pi r squared. What's the radius of the circle? What are we plugging in for r? 20. Okay, clean it up. What's 20 squared? 40. Or 40. Not 40. 400. So the area of the entire circle is 400 pi. But we only want to know the area of that shaded region. So you have to figure out what fraction of the circle is that shaded region. How are you going to set up our fraction? Yeah. The degree of the sector, and the sector is 150 degrees, divided by 360. What do we get when we do 150 over 360? So that sector is 5/12 of that circle. So it's going to be 5/12 of the area. So what do we have to do with our fraction and the area? Multiply them. Oops. So we're going to do 5/12 times 400 pi. So again, we're leaving it in terms of pi. So we're doing 5/12 times 400. What do we get when we do 5/12 times 400? Do math in a minute. 500 over 2. Again, might get some goofy fractions. That's okay. So the area of that sector is 500 over 3 pi cubic yards, or square yards. Question? Yes. If it says leave in terms of pi, make sure it's a fraction and has pi. If you wrote it as like 1.5 pi, I'm probably not going to be picky about it. But if you're rounding it, write it as a fraction. Good question. Other questions? Go ahead and try that one problem at the bottom on your own. I'll get you started on it. We're going to be dealing with the arc XY and the sector. Okay, so we have to figure out some measurements there. We know part of the circle, this blue part of the circle is 240. How are we going to figure out that orange part of the circle? Yeah, the entire circle is 360, so if we do 360 minus 240, what's the length of that orange part of the arc? 120. So this arc is 120 to help you out with the rest. Okay? And now you can do the rest. Try that on your own. If you have questions, when we check your answer, let me know. I'm happy to help.